Welcome, amazing people. In the last video we talked about product rule, and now we are on to quotient rule. If you haven't seen those, you will need to see that before you go on to this one. The quotient rule says if we have a function that's the quotient of two different functions, g divided by h, then the derivative of that function is the bottom function times the derivative of the top function minus the plain old top function times the derivative of the bottom function all over the bottom function squared. And that's a lot to remember, so this is very, very helpful for most. In fact, you'll hear me say this probably on every problem that I do when I go into the notes. If we refer to h as the low and g is the high, it's our low function, our high function, then what we want is the low derivative high minus high derivative low over the square of the thing below, or low d high minus high d low over the square of the thing below. So I find this really, really useful just to say in my head as I'm setting these up. And the one thing that's important on this, if you look back to this, it really doesn't matter whether we put this first or this first. I've seen some do both ways because we're adding, but this makes a difference. We need the product of the low and the derivative high on the left, so we have to be a little bit more careful on this one to end up with the correct answer. So low d high minus high d low over the square of the thing below, and like I said, you will hear me say that starting right now. We have a high function, we have a low function. Our high function is x to the fifth. So for just one time, I'm going to set this whole thing up. I'm going to use an extra step here. So f prime x is, we want the low function, low d high, so I still need to take the derivative of that. That's low d high minus high d low over the square of the thing below. So that's that step. Usually I skip and I just go straight to the derivatives. And so normally I would go straight to this step right here. I'd go low d high times 5x to the fourth minus high x to the fifth d low. D low is just 4x plus 0 over the square of the thing below. And now, danger time right now. It's definitely kill a puppy time right now. People will be tempted to cancel this 2x squared plus 2 with this, but you can't, because 2x squared is not a factor of the top. What we are going to do for our final answers is factor the numerators. So in this numerator, I see I can take out an x to the fourth. Maybe I'll do, I think I'll just go ahead and do that. This term has an x to the fourth. This term actually has an x to the sixth eventually. I'm going to take out an x to the fourth, and I get x to the fourth times the 2x squared plus 2. When I take out an x to the fourth, I've got a 2x squared plus 2 times 5. I've got a minus. This is 4x to the sixth. When I take out x to the fourth, I've still got 4x squared all on star. And let's simplify that. I get x to the fourth times, I'm going to do this all in one step here, 10x squareds minus 4x squareds, 6x squareds plus 10 on 2x squared plus 2 squared, or 2x to the fourth factor a 2 out of this. 3x squared factoring out a 2 plus 5 all on 2x squared plus 2 squared. Remember what I said in the last video? Calculus easy. There's calculus, which we can probably do in one step. Algebra presents a little bit more problems for us. All right, that's where we have to be very, very precise. So let's try it. F prime, low D high. So here we go. Low D high 10x minus high 5x squared D low times 20x to the fourth over the square of the thing below. So now I take a look at this term, and we could simplify this term first, but I know I can factor out of this term and this term a 10 and an x. So I get 10x times, from this term all that's left is the 4x to the 5th plus 3. Oh, my dogs are going nuts this morning. Minus, factor a 10 out of here, and I get 2 times 5, 10. Factor an x. I've got an x and 4 more x's, x to the 5th, all on star. Must have a squirrel in the backyard or something. And let's see what we end up with here. I get 10x times 4x to the 5th minus 10x to the 5th. That's negative 6x to the 5th plus 3 on star. So maybe I'd factor a negative 3 out of these. So that would make it negative 30x. Taking out a negative 3 gives me 2x to the 5th minus 1, all on 4x to the 5th plus 3 squared. And this is a good time to talk about why we want to have that in factored form. As I mentioned on the product video, oftentimes we're interested when these derivatives are equal to 0. If I set this equal to 0, I can now see that 0 is a 0, and I could take this and say, let's see, x to the 5th equals add 1 divide 2, x equals 5th root of 1/2. That's where that's 0. Zeros in that in real world problems gives us a pretty interesting portion of the graph. It's where a particle might stop. It's where we have no slope on the graph at that point. So it might be a maximum or it might be a minimum point on the graph might occur at either 0 or the 5th root of 1/2. Okay. Oh, this was a nice one. I like that. I like having the constants up here for these next couple problems. Here we go. F prime. Low. But D high is 0. Derivative of a constant. Remember, y equals 4 is just this. What's the slope of that? 0. So that's low D high minus high D low. Derivative low is 2x all over the square of the thing below, x squared plus 5 squared. Oh, this is a great one. I end up with negative 8x in the numerator on x squared plus 5 quantity squared. And that is it. So probably would have been a great first problem for us, but it's a nice little relief after the others. Go ahead and try 4, and I'll be right back with you. Okay, F prime, low, 2x cubed plus 3, D high 0, minus high 4, D low 6x squared, all on the square of the thing below. Again, I can't cancel a 2x cubed plus 3 with a 2x cubed plus 3, not a factor. So I end up in the numerator negative 24x squared on 2x cubed plus 3 squared. Okay. And now 5 more like 1 and 2, but an awful lot like 6. So I'll go through 5. You'll give 6 a try. Low f prime x equals low 4x to the 5th plus 2. Low d high 25x to the 4th minus high 5x to the 5th d low 20x all on the square of the thing below. Can't cancel. What can we factor out? I can actually factor out from these two terms, like, see, this is 100x to the 6th, right? So I can factor out a 25 and an x to the 4th from this big term and this big term. So 25x to the 4th leaves me 4x to the 5th plus 2 from this term minus 25x to the 4th times what is this? 4x squared here. All on star. So let's see, that's 25x to the 4th times 4x to the 5th minus 4x squared plus 2, all on 4x to the 5th plus 2 squared. And at that time, if you like, you could factor a 2 out of here. I'll dot, dot, dot. And you need to give number 6 a try. F prime, low, 4x squared minus 3, d high, 20x cubed, minus high, 5x to the 4th, d low, 8x, all on the square of the thing below. Low d high minus high d low, all on the square of the thing below. This term is really 40x to the 5th. So what can I factor out of here? And here a 20x to the 3rd. It's not always the whole thing here, but it's nice when it is. And that leaves me with the 4x squared minus 3 minus 20x cubed times what is 40x to the 5th? I need a 2x squared. All on the square of the thing below. I'll just do my on star here. So that gives me 20x cubed times 4x squared minus 2x squared, 2x squared minus 3. Sorry, that blends into that fraction. That is a fraction too much. All on the square of the thing below, so all on 4x squared minus 3 squared, and we've got it. And if I was interested when that was equal to 0, this is just kind of an add-on. I would get x equals 0. That's a triple. That's multiplicity 3. And add 3, divide 2, take the square root, plus or minus square root of 3 on square root of 2. That's where our object stops. That's a possible location of a maximum or a minimum that's going to be. This is all warm-up for talking about maximum, minimum, real-world type situations. Okay, I'm going to stop that one. It's a good time for you to work on that first half of the notes, and then the next problem's similar. There's just maybe a tiny bit more going on to 6 more in the next video.